Okay, so now let's discuss the logarithmic inequalities. So this is again an additional, or this video presents additional examples on the logarithmic inequalities, and the part 1 for inequalities is posted on the description box. So we have solved each of the following inequalities. So we have these 5 examples. Now take note, we have these rules. So if we have this form, log of a base b greater than c, then this is the same as a is equal to b raised to c. So the direction is here. Let's start with this, not the base. Okay, so let's start with here, and then the base, and then equals c, or the inequality, and then c. Okay. So for number 2, if we have this, then it will follow that a is greater than or greater than c. So meaning number 2 is just like the one-to-one property for inequalities. Okay, as long as they have the same base. Now take note that these two statements hold true regardless of the inequality symbol. So meaning if it's greater than, so you use greater than. If it's less than, you use less than. If it's greater than or equal, you use greater than or equal. If it's less than or equal, you use less than or equal. So that is the meaning of this statement. These two statements hold true regardless of the inequality symbol. Now, it is also important to note that before you solve, we must also find the intervals of each term where each term is positive or defined. Meaning, in this particular example, so for this one, we must know first for what value of x that this log of x base 3 is defined, for what value of x that log of x base 4 is defined, for what value of x does log of x plus 8 base 6 is defined, for what values of this of x that these two are defined, and for what value of x that this is defined. Okay, so let's start. Number 1, we have log of x base 3 is less than or equal to 5. So by the definition of logarithm, so we'll check first for which values these are defined, or this is defined. So take note that with this, x must be positive by the definition of logarithm. So this is our first interval, x greater than 0. So that means 0 to positive infinity. Okay, that is the interval form for x greater than 0. Now, let's use the property number 1. So we'll start here, right? So x, then the base, and then the 5. So we have x less than or equal, then we have 3 raised to 5. Okay, and then next, of course, is we'll just expand 3 raised to 5. It is equal to 243. Okay, now we're done with this part. The last part is, of course, to get the intersection of these two. Okay, intersection of that two. So meaning, so if this is the number line, we have the negative infinity, we have the positive infinity here. So let's label 0 and 243. Now x greater than 0 is this portion, greater than towards that one. X less than, okay, greater than 0, so it is parenthesis. Now this is less than or equal to 243, so this is bracket, and then less than, so towards the left. So all we need to do is find the intersection. So this is the intersection, right? So therefore, our answer is from 0, so this portion from 0, parenthesis, to 243 bracket. Okay, so this is the intersection. So from x is greater than 0, so we read this one as x greater than 0 but less than or equal to 243. Or you can write it this way in interval form. Okay, number 2. So again, we have this. So let's check for what value of x that this is defined. So by the definition of logarithm, x must be positive. Now the same with number 1. So from here, x is greater than or equal to 4 raised to 3 by the property. So here, so 4 cubed is 64. So again, this is we'll find the intersection of these two. Okay, if you want, you label. So x, so this is 0, and we have 64. So 0 towards the positive infinity because greater than 0. And then 64 greater than or equal, so bracket to positive infinity because it is greater than, so towards the positive direction. So what is their intersection? Of course, we can clearly see that it is this one. So their intersection is from from 64 to positive infinity. So we have 64 to positive infinity, or basically this is just equal to x greater than or equal to 64. Okay, greater than or equal to 64. Number 3. Okay, so we have this. So again, by definition, let's check that this must be greater than 0. Okay, so transpose x must be greater than negative 8. So this is our first interval. Now let's solve for this one. Okay, so again, we'll start here and then less than or equal 6 raised to 2. Okay, so we have 36. And then transpose. So 36 minus 8 is 28. So therefore, we have these two intervals. Okay, so we'll take the intersection. So x is greater than negative 8. So this is negative 8. And then we have less than or equal to 28. So greater than 8, so we have this. Then less than or equal to 28, so we have that one. So the intersection is this portion. So it means that our x is greater than negative 8 but less than or equal to 28. Okay, or in interval form, we have from negative 8 to positive 28. Number 4. So by the definition of logarithm, let's check first. So 3x plus 2 must be positive. So transpose, we have negative 2. X is greater than or equal to negative 2/3. And for the other part, 2x plus 5 must be also positive. So 2x is greater than negative 5. Then dividing both sides by 2. Okay, so these are the first two intervals. Now let's solve for this one. Okay, so by one-to-one property, both of them are log base 5. So this is just equal to 3x plus 2. It's also less than 2x plus 5. So transpose, 2x will become negative 2x, 2 will become negative 2. So x is less than 3. So therefore, we have three intervals. The first one, we have x negative 2/3. We have the x greater than negative 5/2 and x less than 3. So let's label. So negative 2/3 is here. So this is negative 2/3. And then negative 5/2, that is negative 2.5. So that's much farther here, negative 5/2. And then x is less than 3. So the first one is this, so it's greater than, so parenthesis. The other one is this, so parenthesis. And then the last one is less than. So less than, this is parenthesis to the left. So take note, their intersection is this part. Okay, their intersection. So it's from negative 2/3 to 3. Okay, so x is greater than negative 2/3 but less than 3. or in interval form, we have this interval, parenthesis, negative 2/3, comma, 3 parentheses. And last example, if we have this, so by the definition of logarithm, 3x minus 1 must be positive, so transpose, and then x must be greater than 1/3. Now let's solve. So this is equivalent to 3x minus 1 greater than 5 raised to 1. Then transpose negative 1, that is equal to positive 1. So we have 3x greater than 6. So dividing both sides by 3, so 6 divided by 3 is 2. So let's get the intersection of the two. X greater than negative 1/3 and x greater than 2. So we have negative 1/3 here, and then we have 2 here. So this is parenthesis, it's greater than only, not greater than or equal. And this one is also positive, it's greater than. So therefore, this is our intersection. So it's up to positive infinity. So therefore, x is greater than 2 or from 2 to positive infinity. Okay, so there are two things you need to know. Again, okay, you must remember this. So you must check this. Okay, thank you for watching.